What shape is a quadratic function?
Square.
Line.
Thank you, Mary. It is a parabola. Remember when we went to parent, we talked about parent functions earlier this year. Okay?
That's a good start.
In order to learn how to graph a parabola and a quadratic function, we have to have a couple things. This unit we talk about standard form of a quadratic function. Later on we will talk about vertex form. But the standard form of a quadratic function looks like this. F of x, you can think about f of x like it is y, but function notation says that it's f of x. Okay? The standard form for a quadratic function is ax squared plus bx plus c. A cannot equal 0. And the reason that a cannot equal 0 would mean the x squared term would not be there, which would mean I'd be left with just a linear function. So if a was 0, it's not a quadratic. It's not going to give me a parabola. Keep in mind, a is always associated with the x squared, b is always associated with x, and c is always the constant, no variable with it. All of those things are going to be important. We're going to identify at the start of every problem, we're going to identify what A equals, what B equals, and what C equals, and we're going to use all of those in order to find our points. With lines, I told you needed to have 2 points. With parabolas, you need to have 5. That being said, most of those points are going to be found with some information that I'm about to show you, with doing reflections. You're still really only going to be chugging and plugging 2 points like we did before. Plugging and chugging, I guess. Okay? So, I'm going to put something on the screen here in a second. If you would want to screenshot it from our book, you can. However, what's in the book has more information than what I'm putting on here because I'm sort of leading you there. It would be my preference that you took a picture of the screen. And this is what I'm talking about. And I'll talk about all these different things and what they mean here in a second. Talk about what's going on here, okay? There's lots of things that are important, and there's properties that exist with every parabola. First of all, parabolas have what's known as bilateral symmetry. You may remember that from biology class. It means this line of symmetry here, this imaginary line of symmetry or axis of symmetry, splits the parabola in half so that each side are exact mirror replicas of the other side. Okay? The vertex, sort of the bottom of a parabola that opens up, lies on this line of symmetry, the axis of symmetry. That's critical. Okay? The point acts as the place where the parabola gets split and the mirror imaging starts. The shape on the left side of this line and the shape on the right side of this line are the same shape, just going in sort of the opposite direction. Okay, our y-intercept is still our y-intercept. It's the spot on the graph where it hits the y-axis. Now notice here, this point that they came up with on this particular graph is the reflection of the y-intercept. So we're going to find the y-intercept, and then we're going to find this distance and go that same exact distance the opposite direction from the line of symmetry, and that's where we're going to come up with another point. On this graph, you see 3 points. We're actually only going to have to do work to find one of them, and then we're going to have to find 2 more points. Okay? And when we go through an example, I'll show you how that all goes. Now, here's sort of the steps. The most important things to find first are the equation for the axis of symmetry. I can't stress enough that the axis of symmetry is an equation. Okay, it's a vertical line, which means it's x equals something. And we'll talk about what that something is in a second. And then the vertex, that bottom point or the top point if it opens upside down, that vertex that lies on the axis of symmetry. Every time we're doing a graph of a quadratic function or a graph of a parabola, we need to identify those things. Again, the vertex lies on the axis of symmetry. And you're going to see why that's really important here in a second. So when you find the equation for the axis of symmetry, here's what we've done. You've actually found the x-coordinate of the vertex. Because the axis of symmetry is the equation x equals something, that something is the x-coordinate of the vertex. Which means all we need is the y-coordinate of the vertex, and we have the vertex. So I'm about to show you the formula for the equation for the axis of symmetry, and then you'll see what we need to do from there. This is the equation for the axis of symmetry. The equation is x equals negative b over 2a. It's an equation. When we get to a quiz or test, make sure you write it as an equation. So, here's the thing. So in addition to finding the axis of symmetry, we're also asked to find the y-intercept. Now here's the thing. What do we know about the y-intercept, besides that it crosses the y-axis?
It's on the Y.
It is a point.
X is 0.
Thank you. X equals 0. Okay? X equals 0. That's important. The x-coordinate of the y-intercept is still 0, just like it was before. So think back now to the beginning of this lesson, and I showed you what standard form was, right? F of x, or y, equals ax squared plus bx plus c. So if x equals 0 to find the y-intercept, what's the y-intercept? In general, if I had ax squared plus bx plus c. No. No. If I plug 0 into that equation, what will I get?
0.
No.
1. 2.
Stop just saying random things.
Negative 1.
No, that's still random. Okay, take a look. So if I plug 0 in for x,
Go find C.
I just have c, which means c is the y-intercept. Okay? So another way that you can think about it is this. The y-intercept is going to be this point 0, comma, c. So when we find the y-intercept from our equations, there's no work to do. Because all you have to do is pick off c. And you have the y-intercept.
But then what's C?
Well, we'll actually have a problem with numbers in it instead of just a, b, and c.
But like,
When we're going to identify a, b, and c at the beginning of every problem. And so once we've identified c, then we've also identified the y-intercept.
so C will be a number.
C will be a number, yes. A will be a number, b will be a number, yes. The point here is that if I plug 0 in for x, because the y-intercept means x has to equal 0, that the ax squared term drops out, the bx term drops out, and I'm left with just c. So we can pick the y-intercept off right from the equation.
But what's C? What are you graphing?
It's going to
It's
change
the
for every
y-intercept.
problem. Okay? Alright. Here's what you're going to have to do for your homework. So take a picture of this screen, please. Here's a problem that, so like this will be the directions and here's the problem, okay? So let's try to break down what you're being asked to do in this problem. Okay, part A has several things that we need to do, but none of them are hard, okay? We got to worry about part A first. My equation here, f of x equals x squared minus 4x. My first question, we need to identify A, B, and C first. What is A?
0.
1. What is B? What is C? 0. There, it would normally be here. If you really feel the need to write the number in so that you know that C, the constant, the number by itself is 0, you can write it in. I don't think you have to write it in. You just need to know that C never has a variable with it. Okay? So I want you to write out in your notes, in your homework, on your tests, on your quizzes, I want you to write out this line, A equals 1, B equals negative 4, C equals 0, for every problem. Obviously, A, B, and C will change per problem, but I want you to write it out in a way to identify all those things, because we're going to use them all. We're going to use B and A for the line of symmetry and the x-coordinate of the vertex. we're going to use C to find the y-intercept.
Someone has to go to
Let's go through A. The first thing is to find the y-intercept. And the y-intercept is 0, but I want to write it as a point. Okay? So what I'm going to do here is I'm just going to have y-intercept 0, 0. Notice I matched the purples up. That's where that one came from. The x-coordinate is always 0. Now, on the next screen, I'm going to have a table of values, and I'm going to end up putting that y-intercept on the table of values. And on your quiz and test that we're going to take, I will already provide spaces for you to insert those numbers. Okay? So we have done this first part. We've taken care of the y-intercept. Now, the equation for the axis of symmetry means I need to know the equation x equals negative b over 2a. Because I've already identified b and I've identified a, I could just plug those into the formula. It's going to look like this. Again, please write it as an equation. Don't tell me axis of symmetry is whatever this is. It needs to be x equals every time. And as much as I talk about it, you will still make that mistake. Remember that the axis of symmetry is a vertical line, and that vertical line is an equation. X equals whatever this number is that we get when we simplify it. So the negative 4 comes from B, the 1 comes from A. What does this simplify to?
X equals 2.
2. Correct. So my equation, notice it's an equation. The equation, when you are asked to find the axis of symmetry, you write an equation, x equals 2. Do not write axis of symmetry is 2. It has to be an equation. And as much as I tell you this, some of you are still going to mess it up. Remember that the axis of symmetry is a line. And that line has an equation. And it's a vertical line. So make sure to include that.
Wait, I have a question.
So once we know the value of, once we know the equation for the axis of symmetry, we also know the x-coordinate of the vertex. So the x-coordinate of the vertex for this problem is 2. So what I really have right now for the vertex is something like this. 2 comma something is going to give me the vertex. I don't know what it is yet, and we're going to have to figure that out. Okay? But the vertex, that 2, comes from the line of symmetry. So that formula, x equals negative b over 2a, is going to be very important for us.
But I thought we were
So on the next screen, because I've run out of room, I'm going to have my table of values. So I'm going to have one point that I'm going to have is the y-intercept. The other point I'm going to have the x-coordinate is 2, but we don't know the y-coordinate yet. Here's what that table looks like. This is the information I have so far. Okay? I don't have anything more than this. I have the y-intercept, which is 0, 0. I have the vertex, which is 2 something. And that's all I know right now. So at this point, what I'm going to do, we know that the line of symmetry is x equals 2. At this point, I'm going to graph half. Oh, this is the other thing. You need 3 other points. As I said at the beginning, you have to have 5 points in total. So you need 3 more points, because we're going to end up with 2 from the top, and then we're going to need to come up with 3 more, and we're going to talk through that. Now here's my graph of what I have so far. This line is the equation x equals 2. That's the line of symmetry, the axis of symmetry. And notice here that I have my y-intercept also graphed, 0, 0. That's all we have so far. Now, please, as I'm going to leave this up there, relax. Make sure you are using either graph paper or a grid. Do not hand draw these, okay? So at this point, go through your pictures and grab a grid that you've used before, stick it in there, and then I'll let you catch up. Question?
Are we going? Does it have to be a dotted line?
Yes, it has to be a dotted line because the axis of symmetry is not actually a part of the parabola. It's just showing you where it splits down the middle. It's not actually part of the parabola, so that's why we dash it. Here's the thing that we need to finish, okay? The next thing we need to finish is the vertex. If you remember when we were doing absolute value functions, we talked about plugging in points until we figured out where the v made the turn back the other direction. Well, having the vertex as part of our parabola, once we know that, then we know where it splits and when it makes the turn. Okay? So what we need to do next is find the y-coordinate of the vertex.
How do we do that?
Good question. How do we do that? How do I find the y that goes with this x? Plug it in where?
What?
To the graph. The equation.
The equation. Yes, we have to plug it into the equation. So we had f of x equals x squared minus 4x. So I just plug 2 in to that equation and simplify that. Now we're back to chapter 1, simplifying expressions.
Wait,
How did you get that?
So my original equation was f of x,
Why did you put 2 in there?
because that's the x value that we already know for the vertex.
But you already have that. So why would you put it in?
No, we don't, because we want to find the y.
So you have to plug it into the
But
x.
why would you?
Wait.
Because that's how you find the y.
Okay.
You just didn't solve it.
So again, all we had when we went, hold on. When we went through and found the axis of symmetry, we found the x coordinate of the vertex. In order to find the corresponding y, we have to take that x value and plug it into our original equation. And our original equation was x squared minus 4x. So what is all of this?
Negative 4.
-4, okay?
So negative
Now,
4 is y.
so my vertex is
2 negative.
2, -4. And look, it's on the graph now.
Oh my.
Okay? So that's the vertex, which means this graph definitely opens up because it's going to kind of come up to this point here. So it's going to open up kind of this direction, and then the other side will look the same, just reflected the other way. Okay? Now, so far we found 2 points. We're going to be able to use this point to reflect and find another point over here. We'll get to that in a second. We're going to find one more point. So at this point, all we've done is plug one value in to find a point, and that was to find the vertex. Okay? Now, what do you think we should choose for x?
2, 4.
Negative.
4.
Reflection?
4.
Okay, no. This x value is 0. This x value is 2. So yeah, we should choose x to be
4.
1. Right in between. So what it'll tell me is I should have a point. I should have a point in here. Okay. So go ahead and do the same thing. Take this 1, plug it in.
Wait, why do you...
Negative.
When we plug 1 in, what do we end up getting?
Negative 3.
-3. Okay. So the same thing.
Ellie just asked
So I have a point 1, -3.
I just went negative.
And so that's where it appears on the graph. Now that I have those 3 points, okay, the vertex can't be reflected. It's on the x-axis. All I need to do for the other 2 points, I have 3 points. To find the other 2, I just have to reflect. So this one is 1 away, so there's going to be 1 here. This one is 2 away, so there's going to be 1 there. So after I do my reflection, I now have my 5 points without doing much work.
I already did
Yes.
that.
Now,
Wait, what about
the next thing you have to do, okay, you can't just put them on the graph. You have to tell me what the coordinates of those points are.
Okay.
So,
1, 2, 3, 4,
so what are the coordinates of this green point right here?
negative
3, -3. What are the coordinates of this point?
0,
4, 0. Put them in the table.
Why is it in the green 4?
You need to put them in the table.
And then
And what's happening here is these points are reflected. Those are the reflected points. We still have to write them down in the table. Even though I only had to do work for this point here and this point here. So even though we have to come up with 5 points, I really only needed to do work for 2 of them. Bless you. Two came from reflection, and 1 came from C. Now, here's the last thing I want to tell you about. Okay? Unlike absolute value, okay, absolute value that comes to that sharp V. Down here, it's a curve. So when you draw these, be careful. Do not make it sharp looking like a V. Make it look somewhat like a curve at the bottom.
like mine.
It needs to have some curve to it. Now, even on mine, it's not perfect. But try to get that shape close as you can. Okay? Don't make it sharp. It is a curve. So right, this, if we continued this up, it would still continue to open even though slightly. It wouldn't go straight up. It would always continue to open as you go further out to the right. Now, something that I want you to keep in mind, okay? And you've talked about this probably in science class in exponential growth. What will happen, what you will start to see happening in these problems, is the further away from the line of symmetry you go, the faster the numbers will climb. And so you're going to have to be very careful with what scale you use on your graph. Because sometimes when those numbers climb quickly, you will run out of room on your graph right away, and you're going to need to change the scale on your graph. So be careful of that. I want to go over one other example with you because right away you're going to have questions about it, and I want to go through it with you. So let's talk about that. The very first problem that you do, okay? The very first problem that you have looks like this. F of x equals 4x squared. This is the very first problem you do. So we're going to start this one together. Okay, so definitely get this down. Yes, this is going to be your first homework problem. Okay, so let's talk about what's going to happen with this problem. Okay, like I said, the first thing you need to do is identify A, B, and C.
A is 4.
Okay, A is 4.
B is 1.
C is 0.
Okay, so here's why this is important. Okay, so the y-intercept is 0, 0. Remember that the y-intercept is 0, c. C is 0. There's my y-intercept. When I look for my axis of symmetry, okay, this is going to be x equals negative b over 2a, which is what?
4. Just kidding, I don't know.
That is also 0. Okay? So here's what I've got going on right now.
Why is there 2 4s?
The vertex is going to be 0, something. Well, we already know what the point is because the vertex and the y-intercept are actually the same point. If I plug 0 in for x, like we did before, that all of this is going to equal 0. So here's what happens with this problem when there is no b. Okay? The y-intercept and the vertex are the same point. So unlike the problem that we just did, we came up with 2 points. This one we only came up with 1. So here's what you got to be thinking now. Okay? When you look at your grid,
I didn't get that.
you're going to have to wait. I'll come back to it in a second. The vertex, okay, the axis of symmetry, and the y-intercept are all the same point. So when I make my table, okay, this is the vertex, this is also the y-intercept. I still need 4 points now, okay? But we've not really plugged anything in yet. Since my line of symmetry is right here, what do you think I should choose for x? 1. So if I plug 1 in, okay, my equation, again, I'll write that down. F of x equals 4x squared. Okay, so if I plug 1 in, I get 4. Okay, so if I go to 1,
What? I'm so confused. You plugged 1 in.
once we find that, that means I have another point right over here at the same place. So if you want to do that now as a reflection, that's fine. There's another point. I didn't have to do anything. Okay? I just reflected.
So you went for what?
I went 1 away from the axis of symmetry. Now, my next move is I'm just going to have to go 1 further away from the axis of symmetry. So what should I choose for x? 2. So I plug 2 in, and you square 2 times 4. What does that give me? 16. Now that's off my grid already, right? My grid, I'm running out of room already. It's way up here somewhere, and I can't draw it because it's not going to show up. It's higher than that because it'll be off the screen. All right, but I can still figure out how to reflect it, right? So it's 16 high, but how far over to the left will it go?
2.
Okay, so what's the coordinates of the point?
Negative 216.
Negative 216. So there's my points, and now you draw your graph. Okay. Now, here's the thing. Okay, right away as you get into this problem, maybe you find the points first before you decide what your scale should be. Because if you try to draw it like I drew it, it's not going to work. You're going to run out of room really, really quick. So maybe you find the points first, then decide what your scale of your graph should be on your grid, and then put it on there, okay? But ultimately, you're going to see 2 different types of problems. One, where the y-intercept and the vertex are different. And when that happens, like the example that we did, then we've already found one of my extra points. but sometimes the vertex and the y-intercept will be the same point, which means I need to find 4 other points, but that only means I'm still plugging only 2 in and reflecting the other 2.